This is the periodic table. What is the periodic table? This is in front of you. This is our periodic table. Understand? Total in this periodic table 117 elements. 117 elements, but we can study 103. Okay, you are right, 103. Because when we are going to study the properties of elements or any like carbon, look like black, white, yellow, or it is soft or hard, or carbon is a metal or non-metal or gas. So when we want to know the properties, then what will happen? Then we must study both types of properties. We have two types of properties. This is first class again. That's why please need your concentration. Physical properties and second one, chemical properties. Physical and chemical properties. We have two types of properties. Physical means you can see the what is the color of this marker? Black. Okay, this soft or hard. When we want to melt, it can melt easily or maybe it will take time. So these called physical properties. The outlook. The outlook we call physical properties. We call physical properties. But second thing, when you want to combine two things together, like a bottle of water, you want to add here food color or drop of ink or a pinch of salt inside, and then you will shake it. So we call solution. Understand? So when you mix together and you will get the new things, that is called chemical reaction. You studied in previous classes in science. So chemical reactions actually we call chemical property. So scientists, they observe total 103 elements that they can study both type of properties, physical and chemical. This is the first introduction. Now the second one, they arrange, as you said, they arrange element in periodic table. I said, what is periodic table? It's arrangement of elements, is it? When you arrange these all elements in a one table, we call periodic table. How they arrange? Yes.
There are arranged groups and then there are groups.
Okay, groups and periods. Any other? Anyone of you? Actually, they arrange in groups and periods if you want to, and blocks. We have three things we want to study. Number one, we need to study the periodic table. In front of you, that is the periodic table, okay? This is the shape of periodic table. You can see there. See this one. This first, here we have one column. The first one, this central part of periodic table, and this, the right side of periodic table, and two rows are done. So how we adjust these all elements? We call blocks. Okay, like your class in that building. Okay, another class like grade 10 here, grade 11 here, grade 12 in this building. But the smaller all grades are that building. So we arrange. Why we arrange? That you can study easily. Similar situation here, they arrange. They arrange periodic table. Yes, you raise hand.
The down ones are man-made elements and the top left, alkyl metal, metal, non-metals, and other they are noble gases.
That I am going to discuss. Thank you, but yeah, you need the basic things. If my question is still there, how they arrange? There are two answers for that. Yes. Number of. I will make correct a little bit your answer that they will arranged according to the atomic number. Okay, so let's see, we will discuss atomic number and mass number. Okay, first they divide periodic table into 4 blocks. What do you think that is this central part, what we call, which block this one? Blocks mean 4 blocks. First, what is the name? Then you will divide S, P, D, and F. 4 blocks. S, P, D, and F. Where is S? Look at board. These first 2 columns. First 2 columns are S block. This central blue color or light blue color or D. And your right side, this one, what we call P. This whole region, what we call P. And then down there is 2 rows, we call F block. These 2 we call F block. So you must know how many blocks in periodic table. How many? Yes, 4. S, P, D, and F. Where S present, where D, where P, and where F. You must know. And the first 2 columns, again I am going to repeat, as central whole part written about transition element. This one is D. Right side, this light pink and light yellow, these all elements present, we call P block. And under these 2 lines, we call F block. Any question about blocks? Okay. Then next we have groups. How you study groups? How many groups actually in periodic table? How many groups written above there? Here, see this one group, and here also written group. Tell me the answer. How many? 4. 8. Yes, next. 7. Total groups in periodic table 18. How many? 18. 1, 8. 18 groups in periodic table. But these 18 groups divided into 2 parts, A and B. A and B. How many A? 8A and 10B. Please, must focus. 8A and 10B. So if someone calls you that how many groups in periodic table? 18. How many A? 8. How many B? 10. Now, look at here. 8. First 8A. This group 1, 2. Then come on here. 3, 4, 5, 6, 7. And this 0 group are 8th group. So total how many A group? 8. Now, how many B group? 10. So this central part, start from here scandium to Zn, zinc. This whole central part of periodic table, 10 groups are there. And 10B. Understand where is B group present? Central part of periodic table. This one. And where is 8A group present? First 2 on the left side of periodic table. This is group 1, this is group 2. And other 6 group are present the right side of periodic table. You can see here. This one, 3rd, 4th, 5th, 6th, 7, and 8. Any question about the groups? But how you study groups? Groups in a vertical column from top to bottom. You can see here. When we travel from Li to Fr, from top to bottom, understand? From top to bottom, what we call? What we call? From top to bottom, from here, guys. From lithium to francium. Group. Excellent. Because when we study group, you must concentrate that when you are going from top to bottom, that is called group. Not from left to right, from top to bottom. From top to bottom. What we call? Groups. How many? 18. 8A and 10B. Okay, now about groups. Any problem? Why they arrange elements in groups? What you understand? Yes.
To find the element easier.
Okay. Any other? Good. Try to explain. Don't sit, keep quiet in my class, please. Even you are right or wrong. This is another matter. But you have to say something what's come in your mind. Just you sit and wait for the bell and you will go outside, you will never understand the chemistry. Even you are right or wrong. I told you, nobody wrong. All of you are right. Just give your opinion. Share with me your idea that what you understood.
What is the question?
The question is there, why they arrange elements in a group. Suppose from first group they start from Li, is it? And it will finish with Fr. So why they put these all elements in one group? Li, Na, K, Rb, Cs and Fr. Yes, yes. Same system means same properties. Excellent. Because they have both type of properties are similar, either physical or chemical. Did you get now? Both types of properties are similar, physical or chemical. Excellent. Now, the next one is period. How many periods in periodic table? 7. Excellent. These are the periods. See, this is the first one where is hydrogen and the last one is lithium present. Hydrogen and helium. Hydrogen and helium present. These two are group 1. Then, period 1. Then you have to start from here. 2, 3, 4, 5, 6 and 7. So total 7. How many? 7. How we will study? In rows. From left to right. From left to right. How many total? 7. Again same question. Please concentrate now. See, they put this element lithium, beryllium here, Be. Then in same group, group 2, B, C, N, O, F and Ne. From left to right, all elements, they are in same row. Why?
Because of the atomic number, the more you go to the right, the higher the atomic number.
Okay, I will
Because
just
like lithium has like 3, then 4, 5, 6, 7, 8, 9, 10. We go down to 11, 12, 13, 14, 15, 16, 17.
okay, excellent. So I just little help you. You are right. You are near to the correct answer if you want to write in exam. Then atomic number adding by 1. Adding by 1. You can see there. See here lithium 3 as you said. Then beryllium 4, 5, 6, 7, 8, 9, 10. So atomic number added by 1. So when you add atomic number, here one reason actually. This is not answer that atomic number added by 1. Yeah, you have idea that. This is your opinion. You are near to the answer. Understand now? So the answer is correct answer is there when you add one atomic number, is it? Because you are going to travel from 3 to 10, is it? When you want to add one atomic number, what will happen actually with the element? You saw this shape in science like this. Have to fill up or not?
Yeah.
Like here electron, here something is proton and neutron. Okay. So when you add one electron, you have to add into same shell. Like here, you will not create another shell.
Oh, yes, it's for the number of shells.
Yes. You have to, now you can say the atomic number or number of proton added into same shell. Why they put in a one row?
Because they have the same number of shells.
Excellent. Did you get now?
Yeah.
So don't take it like as a story or just like a paragraph. Chemistry book with you, notebook you can, and I will upload the slide also on your platform, and homework you can see from everywhere, and you are good in reading, so you can read yourself, is it? But better to understand it, something in your mind, when you read automatically that concept will fix in your mind. So try to understand something instead of just passing the time. You must participate in class. Okay, it's nothing hard, but we must cooperate. Now, periods are over. Now, when I will put the question in exam, keep in mind. So, I want to give you a very simple trick. You have to draw these two lines, one from left to right and one from top to bottom. Understand? So when you want to study, if you are traveling from top to bottom, from here, from top to bottom, it's mean where are you now? In groups or in periods? Again, if from this diagram you are going from top to bottom, groups. Why? Because this vertical column. You can see the arrow. It means you are going to study about groups. Understand? When you are traveling from, see, this is the top place and this one is down. Like from lithium to francium. You are going from top to bottom. It means you study about groups. But when you start from potassium till Kr, krypton gas, from left to right in periodic table. This is the left side and this one is right side. So when you travel from left to right in periodic table, this left side, this one is right side. So it's when you are in periods. It's mean you are study from top to bottom. Understand? So sometimes it's very simple that you can use this trick that how to study a periodic table. Okay? Just use the arrow from top to bottom and left to right. Then we have two numbers with each element. Is it? You can see here. Please concentrate here. One is written down and one is written up. Is it? Or take another example. This sodium. Written 11 and then 23. Is it? Here 11 and here 23. Take another example. This B for boron. 5 and 11. 6 and 12. 7 and 14. It's mean with each element there is two numbers. With each element there is two numbers. What we will call, one is smaller number and another is greater number. You can see here 11 and 23. Which one is greater? Yes. So you can observe from this periodic table, you can see any element, you can take example of any element, you will get two number with each element. Like one is smaller, one is greater. Don't sleep please. One is smaller, one is greater. Understand? What you call if there is smaller number with element? These 11, written there 11. What do you mean by from this 11? Yes.
It has 11 electrons or
Okay, I agree with you. Any other? He said 11 electrons. You mean the number of electron. Is it? Okay. Any other please? Can we give any other name?
atomic number.
Sorry, loudly. Yes. What we call this smaller number? Actually, we have specific name for smaller number and for greater number. We have specific term we are going to use for that.
The smaller number is the atomic number.
Yes, you are right. First you said number of electron, now you said atomic number. Excellent. Actually, we call the smaller number when any element written X, Y, or Z as written there sodium, like here one is 11, one is 23. Is it? So if there is written 11, you can call three names. Atomic number, what you call? Always smaller number with any element, what we call? Atomic number. Understand? If there is smaller number. Or there is another name. You can call number of proton. Number of proton. Or you can call, as you said before, number of electron. So this, if I call how many proton in sodium, what is your answer? 11. What is the atomic number of sodium? 11. What is or how many electrons in sodium? Understand? I am going to call these three names. Atomic number, number of proton, number of electron. Again, I am going to revise, please. With in periodic table, there are two numbers. There is smaller and greater. The small number is known as atomic number. Atomic number first. But if, because we are going to use this concept, how many proton in sodium? 11. How many electron in sodium? 11. Because atomic number, number of proton, number of electrons are same. Names different, but the quantity is same. Okay, take another example here, oxygen. This one oxygen. How many proton in oxygen? 8. Good. How many electron in oxygen? 8. What is the atomic number of oxygen? 8. Now you understand? Okay, there is second term. There is the greater number here on the top, 23. For 23, we are going to use a specific term that is called mass number or atomic mass number. For this 23, what we call atomic mass number. It's okay now? Atomic mass number 23 or greater number, always what we call mass number. You can say shortcut or atomic mass number. Any question about this atomic number and mass number? It's clear for you? These basic things I am going to carry today. Now, you know about the blocks. These are the blocks like S, P, D, and F, 4 blocks. You know about the groups, periods, atomic number, and mass number. Any question till now? Okay, now. Next, our question is, and I want to explain the answer. That what you said. What's your name? Yes. That I called the question before that how they arrange element in periodic table. Do you remember? So you said that there is a number. I said atomic number. Understand now you what is atomic number? Okay. How they arrange? By increasing, order of increasing atomic number according to order of increasing, not decreasing. You know, increase and decrease. So how they arrange? If there is a question, how they arrange element in periodic table? How they arrange elements in periodic table? So what you will call that time? What you will say? According to increasing number of electron. Better you have to set atomic number or proton, because proton and electrons are same. So better you said according to increasing atomic number. according to or in order of increasing atomic number. This you want to prove, that you will see that how they said that order of increasing atomic number. You know the smaller number is atomic number, is it? Okay. Common in group 1. Here 3, 11, 19, 37, 55, 87. When we go down from top to bottom, what happened with the atomic number? Increase or decrease? Increase. So now you understand how they arrange element in periodic table by increasing their atomic number. Don't forget, by increasing their atomic number. Take a second example. Here, group 2 element. First 4, then 12, 20, 38, 56, 88. So when we go down from top to bottom, within a group, their atomic number increase. So that's why you can say they arrange element in periodic table by increasing their atomic number. Yes, yes.
It's not clear.
It's not clear. So we,
We can see the small number assembly.
okay, I will focus just one. Can you see now this one? VE. Or you bring your chair here. Here, see. This small number is there. Understand? Now it's clear for you? Okay, see now. This number 4, then 12. Because we are talking about atomic number, not the greater number, smaller number. Understand? With each element we have two numbers. One is greater, one is smaller. So we are going to study now the smaller number. That is called atomic number. The question is there again. I am going to repeat the how they arrange element in periodic table. How they arrange? According to atomic number. Increasing, in order of increasing atomic number, not decreasing. So increasing mean here 4 and 12, then 20, then 38. It's mean when we are going from top to bottom with in this column from top to bottom, what happened with their atomic number? Increase. Understand? So in this way they arrange element in periodic table. When atomic number increase, they put in a one group. Understand? Like B, E, M, G, C, A, S, R, B, A, and R, A. These all they put in one group. Why? Yes. Why the atomic number increase? Good. It's depend upon the properties of element. You know all elements are not similar. Like we want to breathe oxygen. We can breathe easily, it's not dangerous for us. But instead of oxygen, if you want to breathe helium, neon, or nitrogen gas, we cannot. First, we cannot. We feel suffocation, like this mask, when we wear this mask, difficult to breathe, is it? This is called suffocation. So instead of oxygen, if you use another gas like nitrogen, because this environment we have all gases are there, is it? This is natural phenomena that we use only oxygen. This is from God. But if there is lack of oxygen, some people they have heart problem. If you are in emergency, go to the hospital. First they will give you the nebulizer oxygen. They will provide you oxygen. And that person before hospital, he was outside. If there is no oxygen, he can breathe what? Another gas. Understand? So we cannot. Why? Because all gases they have different properties. Or those drivers they go inside to the sea, they will take cylinder with them. Is it? Why? They cannot fill nitrogen with cylinder. They fill oxygen with cylinder. Understand? So it's depend their atomic number. Why increase? It's depend upon the properties of element. So the scientists, those they discovered these elements, they fix that number. Do you understand now? Because all are not same. If this beryllium, see, This B, E, and Mg both are same. So why we write 4 and 12? It means there is difference in their physical properties or in their chemical properties. There is difference. That's why they put a different number. Did you get your answer? Now, any one of you have any question, please, about periodic table? Now you can see here. Yes, yes. You want to go? Okay, wash your face, please. Wash your face first, please. Okay, this one is, what is written there?
Explain the relationship between groups, numbers of outer shells, electrons,
Metallic and non-metallic characters. Metallic and non-metallic characters. Now, then second, describe the change from metallic to non-metallic character across a period. So first, explain the relationship between group number. Group number mean a number of outer shell electron. What do you mean by group number, please? Number of protons, okay, or atomic number. Wait for next. You can see here what is the relationship between electrons. Electrons arrangement of atom are linked to a position in periodic table. Mean where they present in periodic table. If I call carbon, where carbon present in periodic table?
carbon is in group 4.
Group 4. Understand? You can see periodic table. Element in the same group have same number of electron in their outer shell. You got your answer? That you said number of proton. So element arranged in a group according to same number of electron. Same number of electron in their last shell or outer shell. For the main group element, the number of group is the number of electron in outer shell. Like how many electron in carbon? 6. Is it? If I call how many proton in carbon? 6. So electron and proton are same. Electron and proton are same. So look at this one. Here I want to explain you one concept actually. Total we have 6 electrons.
Yes.
In first shell we will fill up only 2, is it?
Yes.
And how many left out of 6?
4.
4. Where we will fill up 4? Here 1, 2, 3, 4. So how many electron in outer shell now?
4.
How many electron here in outer shell?
4.
4. So where present carbon in periodic table in group? 4. So you understand now this second statement?
Yes.
This statement you understand that number of group in the number of electrons in outer shell. So how we arrange in a group? According to that how many electron in their outer shell. How many electron in their outer shell? Here how many? 4 electron according to the carbon. The last shell how many electron? 4. That's why we put carbon in group 4. In group 4. You see this one. Like potassium here. They took example of potassium now. This one. From here. This potassium now. So how many electron total here? How many? 2, 8, 8 and 1. In first shell 2, second 8, third 8 and last shell how many? 1. That's why they put in group 1. Understand now? Now another example, argon, AR here. This AR. How many electron total? 18. 2, 8, 8. So this red one, how many last shell electron? This last shell actually. 8, is it? So you can see in periodic table where they put this group. Where argon they put in group 8. In group 8. Understand now? So if someone asks you question that they put element within a group, how they know that we can put carbon in a group 4? How they know we can put this potassium in group 1? And how they know that they know the argon in group 8? From where? We will check the number of electron in their outer shell. If in outer shell, last shell, this red, see here for potassium, how many outer shell electron? 1. For sodium, how many outer shell electron? How many outer shell electrons? So sodium written here. You can see this one. 1. The second one. And how many outer shell electron with lithium? 1. So these all they have 1 electron. That's why they put in group 1 here. See this one. Potassium 1 electron, sodium 1 electron, potassium 1 electron. Did you understand? Their outer shell 1 electron. That's why they put in group 1. Any question? Now see the group 2. How many beryllium outer shell electron? Red 2. Magnesium 2. Calcium 2. So they are put these all elements which group? 2. Why they put in group 2?
Because they have 2 electrons in the
That is your answer. Because they have 2 electron in their outer shell. Because they have 2 electron in their outer shell. Any problem? Come on here, as I gave example before for carbon. In first shell 2, in second shell how many electron in carbon? 4. Why they put carbon in group 4?
because it has 4 electrons.
Okay, come on, oxygen.
6.
Outer shell electron how many? 6. Why they put in group 6?
They have
Because their outer shell having 6 electron. So you understand what is the relation between this one. Explain the relation between group number and number of outer shell. Did you understand this relation?
yes.
That outer shell, how many electron present we will put in that group. That's it. If 10 electron, we will put in the group, that one. If outer shell 5 electron, we will put in 5th group. If 7 electron, we will put in 7th group. Understand the relation? Now, metallic and non-metallic character. Yes.
All metals can conduct electricity. That's how something can conduct electricity, it's a metal.
Excellent. See why they wrote here metallic and non-metallic. First, I will explain you these 103 elements actually. 103 elements divided into 2 categories main.
Metals,
Metals and non-metals. Understand metals and non-metals. Understand now? Metals we call metallic, non-metals we call non-metallic character. Did you understand now? You study in science, all metals they conduct heat and electricity. We call metals are conductor. All metals are very hard. They are, when you cut, you see that shining. But non-metals, they are very soft. Soft like gases, oxygen, non-metal. Carbon, non-metal. Yes.
graphite can conduct electricity and graphite is made of
That I am going to discuss. That is a specific, exceptional case. But 2 main categories. That's why I use the words main categories. So the beginning of class I told you, please focus. It's not you study before. I have no problem that you study before metal, non-metal, character, non-conductor, insulator, and these are. That one is the story. Now, how to utilize these concepts? So you know that graphite, you took the example. But first 2 main categories, metal and non-metals. all metals are conductor, non-metals are non-conductor. Okay now, but some are in between metal and between non-metal. What we call those?
Semiconductor.
Excellent. Semiconductor or semi-metals, because we are talking about metals. Conductor mean when we start the topics conductor and non-conductor, then you can say. But now we are going to discuss what? Metal and non-metal. So those are in between. Sometimes they can act as a metal, sometimes they can act as a non-metal, like silicon.
It's used in computer chips.
Silicon you can use, they use actually in mobiles, in watch, in others electronics device. They use silicon because it is semiconductor and it conducts heat and electricity, but not that much like a metal. That's why we call semiconductor. Semi means small, a part of that matter. Understand now? So in between we call semiconductor, or we call another specific name for those, metalloid. Metalloids. Okay, those they have both type of properties, either metal or non-metal. Understand now? Till now, any question, please?